Hey everyone, welcome back to another Linux tutorial. Today we are diving into nproc command, a simple but incredible useful tool for checking how many processor core are available on your Linux system. Whether you are optimizing performance, compiling software, or troubleshooting system resource, this command comes in handy. This tutorial applies to most Linux distribution, but I will be running this command on Rocky Linux. So let's get started. Let's see the manual page for nproc. The nproc command is used to display the number of processing unit available to the current user. This means it tells you how many CPU cores your system can use, which is essential for tasks like performance tuning, parallel processing, and job scheduling. Let's run a quick example. nproc. On my system, the output shows 4. This means my system has 4 available processor cores. Your output may differ depending on your hardware. Now, why would you need to know the number of processing units? Here are some practical scenarios. When compiling a program from source using a tool like make, you can speed up the process by running multiple jobs in parallel based on the number of CPU cores. Example, like this you can run in proc. So this ensures that the build process uses all available CPU cores, making it faster. If you are running CPU intensive tasks like data processing or rendering, you might want to split the workload across multiple cores dynamically. System administrator often needs to check the CPU limits before assigning a resource to a Docker container, Kubernetes pod, or virtual machines. For example, if you are setting up a Docker container and want to limit it to a half of your CPU cores, you can check nproc and then allocate accordingly. For example, if I am running docker run hyphen name my nginx, I'm running a container nginx and I will allocate CPUs equals to 2 hyphen d nginx. So docker run, it runs a new container and hyphen name my nginx, assign a name to a container, and hyphen cpu equals to 2. It limits the container to use only 2 CPU cores. Hyphen D nginx runs the nginx container in detached mode. Once the container is running, check its CPU constraint with docker. You can run with inspect my nginx. You need to provide the container name and grep hyphen I CPUs. As per this output, this means 2 CPU cores are allocated to the container. Docker represents CPU limits in nanoseconds per second. One CPU is equals to 1 billion nanoseconds. Since you set hyphen CPUs equals to 2, the value is 2 billion nanoseconds. CPU share is used for relative CPU weight. Ignore here since we set hyphen CPUs. Let's take another example. Run docker. I will give name ubuntu hyphen cpus equals to 2 hyphen it ubuntu bash. Since the ubuntu image is not available on my system, so it is downloading it. I will pause the video. Once this is done, I will resume it back. This starts an interactive ubuntu container with CPU limit of 2 core instead of the container. This is my system terminal, so I am logging to the container. Let's run nproc. The output shows nproc returning 4 inside the Ubuntu container, even though you used --cpus equals to 2. This happens because docker --cpu option does not change the CPU count visible inside the container. The system still reports all the available cores. nproc shows 4, but the docker enforces CPU limit at a runtime rather than changing what the container sees. How Docker CPU limits work: instead of restricting the reported CPU count, Docker uses the CPU quota and shares to control how much CPU time the container gets. The container can also see all the CPU cores but is throttled to use only the allowed CPU shares. 2 CPU in this case. Since nproc won't reflect the CPU limit, use cgroup information instead. Cgroup cpu.max. So nproc inside a container always show all the host CPUs because the Linux namespace do not change what is visible. Docker limits CPU usage, not CPU visibility. Use cgroup files like sysfs/cgroup/cpu.max file or docker stat to check the actual CPU enforcement. As per the output, it allows CPU time to CPU and the base period is default 100 milliseconds. So let's explore the useful options. The nproc command has a few useful options that can provide more insights into your system CPU allocation. You can tell nproc to ignore a specific number of cores using the --ignore option. This is useful when you want to reserve some CPU power for other process. Example, nproc ignore, I will say 1. So it without option it will show 4 and with option it shows 3. If you have a 4 CPU cores, this will return 3, meaning one core is left unused. This is handy for a system administrator running heavy workloads while keeping one core free for system tasks. By default, nproc shows the number of logical cores available to the user, which includes hyperthreading. If you want to check the physical cores, you can use lscpu grep core per socket. This gives a deeper insight into how your CPU is structured. Additional way to check the CPU information: while nproc is the great for quick check, here are the few other commands you can use for detailed CPU information like lscpu. lscpu shows a complete breakdown of your CPU architecture, and the next command is cat, let's see, proc cpuinfo, displays detailed information about each CPU core. If I want to grep processor slash proc CPU info, I want to see the count, it's 4. This also counts the number of logical processors similar to nproc. And that's it for this tutorial. We have explored the nproc command, its real world applications, and how it helps system administrator and developer to optimize their workflow. Whether you are compiling a software, managing a resource, or troubleshooting a performance, nproc is handy tool to have in your Linux toolbox. And remember, this applies not just to a Rocky Linux, but to most modern Linux distribution. If this video helped, be sure to like, subscribe, and hit the bell icon for more Linux tutorials. Check out our other videos for more system administrator tips. See you in the next tutorial and thanks for watching.